Welcome back to lecture. In this lesson, I'm going to talk about polynomials and factoring and just different ways of looking at these. So what is it? What is a polynomial? A definition of a polynomial in X is that a polynomial in the variable X is an expression of the form I've got a to the n, x to the n, the a to the n, a to the n minus 1, a to the n minus 2, all the way down to a0 are constant terms. So this could be like 5, 4, 3, 2. The x to the n is the variable, and the highest power, that highest power, the n, is the nth degree. So if this was the highest power was a third, it would be a third degree polynomial. If it was a 2, it would be a second degree polynomial. Okay. So the coefficients a to the n, a to the n minus 1 are real numbers. A to the n is not equal to 0 because that would make the leading term 0, and you don't want that. You would be starting with this one. And the exponents n minus 1, n minus 2 are whole numbers. The term a to the n x to the n is called the leading term. This is the highest power term. The coefficient a to the n is the leading coefficient, and the exponent n is the degree of the polynomial. So in the preceding definition of subscript notation, a to the n, a sub n minus 1, and so on, is used to denote the coefficients of the term. Subscripts notation is used rather than lettered variables such as ABC and like when a large or undetermined number of terms is suggested. So that way we can have some arbitrarily large polynomial is all of it. It could be used with the same definition. So a polynomial with one term, just one of these terms, is called a monomial. A polynomial with two terms would be called a binomial, and a polynomial with three terms is called a trinomial. So to add or subtract polynomials, all we're going to do is combine like terms and do the addition or the subtraction. Okay. So here's an example of that. I'm going to add the two polynomials, minus 4w cubed minus 5w squared plus 6w plus 3 plus the polynomial 8w squared minus 4w plus 2. And all we're going to do is just remove the parentheses here. With the plus, I can just keep the same signs, and then I'm going to group. I only have 1 to the third. This is the third power here. I only have one of those. 2, I need to combine and group my w squared terms. Negative 5 plus 8 gives me the plus 3. My w to the first, I combine, group and combine. 6 minus 4 is 2w. And then my constant 3 plus 2 is to the 5, is 5. When I do subtraction here, I'm taking all of this stuff from my first one minus all the stuff from the second one. So I'm subtracting two polynomials. Here, I can just remove these parentheses. I've still got all of this is just the same. But here, if I want to do this, I need to change the sign of everything inside. So this goes to a negative, positive. I'm distributing a negative 1, and across this one I get the negative 2.1b squared. Now I can do just like I did above, remove the parentheses, and then group like terms. A squared b, do I have another a squared b? Yep, there it is. So I group these together and then add the coefficients. I'm looking for ab, got another ab over here, add the group and add the coefficients. And then I group my b squared terms, add the coefficient, negative sign. So here's just a point of interest worth noting that 16th century brought the use of many modern symbols in algebra. Mathematicians Christoph Rudolph and Richard Seifel of Germany introduced the plus and minus signs, and Robert Record of England introduced the modern equal signs. And these are used all over. So it's kind of an international language now. If we have polynomials and we want to do addition or subtraction, we can do them by doing them in column. Sometimes you'll see this. If you just doing them and you want to kind of do a nice way of keeping track of everything, put all the columns, group the columns together of like terms, and then you're going to do just like arithmetic. Now here I'm subtracting. So I need to do this negative, 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 and change the sign of everything in here. And then I do my addition. So this was from the subtraction. If I'm just doing addition, I'm just adding them straight down. and making sure I'm doing signed arithmetic. 6.1 minus 2.6, 2.9 plus 4.1. So if it's a plus, I don't have to worry about changing the sign, I just do it. But if I've got a negative, I have to do the distribute the negative one across each one, changing the sign of each. Okay. So let's go through a couple examples. I'm going to get rid of myself here, and we'll continue on. So I'm going to multiply polynomials. To multiply polynomials, we use the distributive property to multiply each term in the first polynomial by each term in the second polynomial. So here it says multiply and simplify. So I want to multiply these out. And the way I multiply polynomials is go from each term and distribute. So I'm going to start with the first term in the first polynomial, distribute across all terms in the second polynomial. 4x times x squared, 4x times x squared, 4x times negative 6x, 4x times plus 1/2. Once I finish distributing all the way through, I go to the next term and I just start distributing. 2x squared minus 12x plus 2 times 1/2 would give me the 1. I do the multiplications, and then I start grouping like terms. I've only got one cubed term. That's going to be my leading term, 4x cubed. I group all my squares. There's another one. Put those together, group and add. Minus 24 plus 2. My x's, there's a similar x, so I'm going to group those together to give me my minus 10x. And finally, my plus 1. So here's another way we can do multiplication if I do them vertically. To me, I like distributing, but this works well getting started out, and it kind of mimics what we do when we're multiplying numbers. I align each one according to the terms, like terms go vertically, and then I start multiplying. 2 times 1/2 gives me the 1. 2 times the negative 6x gives me minus 12x. 2 times x squared gives me 2x squared. I finished doing all of those, so then I move on to the next one. 4x times 1/2 would be 2x, and I want to keep these in line so that I can just add them, so I'll put my 2x followed there. 4x times negative 6x gives me my minus 24x squared, right in line with that x squared, and then 4x times x squared is 4x cubed, and then I just add 4x cubed minus 22x squared minus 10x plus 1. Here's something we're going to run into frequently. When I multiply two expressions of the form, two numbers, a minus b and a plus b. I'm going to multiply a minus b times a plus b, and these things are called conjugates of each other. So the product of two conjugates result in a difference of squares. So watch what happens. A times a is a squared. A times b is my ab. Then I go minus b times a, which is the same thing as ab, so I'm going to go ahead and write it as ab. And then negative b times b is my negative b squared. Well, here my AB and my minus AB is always going to cancel no matter what. As long as I've got conjugates multiplying, these are always going to be 0, and I end up with a squared minus b squared, the difference of squares. Difference of two squares, and I can rewrite this as needed as either a squared minus b squared or a minus b, a plus b. Sometimes I want to go this way, sometimes I want to go backwards and get me these two, so it's a factoring type deal. So an expression of the form a plus b squared or a minus b squared is called a square of a binomial. In expanded form, the product is a perfect square trinomial. So a plus b squared, really all I'm doing is saying a plus b times a plus b and then multiplying, distribute. A times a is my a squared, ab, ba, which is ab, the same thing, and then b squared. So now I can combine these two terms as 2ab, and this is called a perfect square trinomial. 3 terms, and it's based on a perfect square. Anytime I multiply, anytime I expand this perfect square, all I'm going to do is look at this formula, and I'm not really going to look at the formula, but I'm going to recall and do what it says. I want to square the first term, I'm going to multiply a times b and then double it. So it's always 2 times a plus b, and then I'm going to square the last term. So no matter what it is that I'm doing, I'm going to square the first, multiply the 2 and double, and then square the last term. And I can easily write out the squared part. Same thing with a minus b squared. I'm going to square the first, multiply the 2 together, negative ab and doubled, minus 2ab, and then square the last. So the only difference is here I'm going to have this negative, but that's naturally leads, because if I multiply the 2 together, plus a plus b, I get my ab, plus a minus b, I get my negative ab from here. So again, these are our special cases that we kind of need to know off the top of our heads, recognize. We're going to be using them back and forth. The quicker we kind of get to memorizing, the better. I recommend doing some flashcards here, back and forth between these two. One side have this, and just remember how to do it. And then on one side again this, on the back side this, front side, back side, and then go from back and forth. Start with this, go here, here to here, here to here, and then flip them over, go here, and just do it off the top of your head. A squared minus b squared, a squared plus 2ab plus b squared, a squared minus 2ab plus b squared. Then go to this side, say, whoop, I've got a perfect square. The b and the a, if I multiply together, I get the ab, and that's the doubled. So I've got the a minus b, a plus b. So these don't necessarily have to be integers. They can be other numbers. You know, we can still do the very same thing when I'm multiplying these together. So let's multiply these two. Take this term, multiply 3 times 2, 6. Square root of x times square root of x is the square root of x squared, which is just the x. 3 square root of x times negative 7 plus 5 times 2 square root of x, and then 5 times the negative 7 gives me that negative 35, and I just simplify from here. Here's the negative 21 plus 10 square root of x. That gives me the minus 11 square root of x as I simplify. So here, I want to recognize these look like a product of conjugates. Something plus something else, that very same something from here, and I've got a change of sign for those. So that's just this squared, 16 times 5, minus this squared, which is just 6. So now I just get the 80 minus 6 and the 74. Perfect square, the square of a binomial. Square the first one, 9x squared. Multiply the 2 together and double, so that would be 6x. 6 times the square root of 2x. And then square the last one, just gives me the plus 2. So we're going to want to go back and forth between expanding things out, multiplying them out, and then bringing them back into a factored form. We like to have them factored for a number of reasons. One, if we're doing division, we can cancel out common factors between the numerator and the denominator. So we now look at the multiplication of polynomials in reverse. The goal is to decompose a polynomial into a product of factors. This process is called factoring. So we're going to spend quite a bit of time in the course doing factoring. It simplifies things. We just need to know how to do this. So there are many techniques used to factor a polynomial, but the first step is always to factor out the greatest common factor. So anything in common between these I want to pull out. Okay. So for example, each term in the polynomial 12x to the 5th plus 16x to the 4th minus 24x cubed shares a common factor, that x cubed. So I certainly want to take that out. And also a greatest common numerical factor of 6. 6 divides into each one of these. That's the biggest, that's the greatest one that's going to multiply in. Okay. So I'm going to take out the 6 and the x cubed. So if I divide 12x to the 5th by 6x cubed, I get my 2x squared. do the very same, factor it out or divide it by 6x cubed. That gives me the 3x. And the 6x cubed here would give me the -4 times the 6x cubed. So now here's where they factored out, and now I pull them out of each one. Okay. Once I factor, I can always go back and check. All I have to do is distribute, remultiply them out, and I should get the original thing, original problem. So sometimes it is preferable to factor out a negative factor from a polynomial. For example, consider the polynomial minus 4x squared minus 8x plus 12. If we factor out -4, then the leading coefficient of the remaining polynomial will be positive, and in this case 1. This is the easiest one. If we can factor as we go and look at this, this is what we really would like to have, is the leading coefficient 1 here. If I get that, it makes factoring so much easier. So in this case, I'm taking out a -4. This turns this into x squared minus 4. That would be the plus 2x left. The minus 4 here would be the -3. And then that's the way I write it. So sometimes we can do some factoring by grouping, and this is kind of a trial and error type thing. We try to group these things together, merge them around, and see if there's anything common I can take from here, anything common I can take from there, and then hopefully, or if it does end up that I have some common terms here, then I can basically factor that out. So this is what I'm going to do here. I see that I have a 2a common I can take out. So 2a from here leaves me just the x. A 2a from here just leaves me a -3y. And my 2a's out front, 2ax minus 6ay. And then I'm splitting this into this piece, so I'm taking out a -5 here. I'm left with an x. And because it's a -5, this ends up being -3y. And in fact, one of these things, if you can kind of see one of them, you're trying to look and see if I can put this into the same order and terms as the preceding one. And then I can just basically factor out this from both. So now I pull out these to x minus 3y, and what's left, the 2a and the -5. And again, those are special cases. It comes up a lot of the higher power polynomials. That's about the only method that you can really look at. Okay, so let's look at factoring a quadratic trinomial, and the leading coefficient is 1. Here's the easiest case. Okay, what I'm looking for, you remember when I multiplied these things out, if I just multiply a plus b to a plus b, I get the first thing is squared, the second thing is squared, and then I end up adding what the factors would be. So here's what I'm going to do. I'm going to take the last thing, I'm going to look at factors of 12, the factors of 1. In this case, there's only 1, so this is just an x and an x. But it must add up. When I multiply them out and add these things, I should get -x, or it should be 8. So here I'm adding, so they should sum. Is there anything, so here's the only thing I'm asking, is there any two factors of 12 add up to be 8? 12 and 1 is a factor. 12 and 1 doesn't give me 8. 2 and 6, 2 and 6 give me the 8. 3 and the 4 wouldn't work, that would be the 7. So this needs to be the 6 and the 2, and this tells me what the sign needs to be. They both need to be negative, because when I multiply that last two terms, it has to be positive. So they're the same sign because of that positive. This tells me what that same sign is. So I've got those. This is basically how I do it. And if this is a term other than 1, I do the same thing, but I just have to take into account these are different factors of all the x squared as well. So if I look here at the skill practice number 6, I want to know two factors of 14 that's going to give me the 9. They're both the same sign, so they're going to add to this. They need to be a negative. 14 and 1 doesn't do it. 2 and 7 would do the 9. So they need to be x minus 2, x minus 7 for that one. So there's the rules that I've kind of mentioned. I wanted to factor this. I've got an ax squared, I've got a plus here and a plus here. So they have to be the same sign, because when I multiply them together it has to be positive. And when I add them together, if this one's positive, that means that these things have to be positive together. A, the leading coefficient I'm assuming here is just A is equal to 1. So I get x plus something times x plus something, and it has to be the factors of C. Here's my 1. So I'm looking for factors of this, both the same sign, have to be plus to match that one. And I'm looking if they add up to be 3. 2 and 1 would give it to me. Maybe 1 and 2 would be the very same thing. Here I'm assuming that for this one we're talking about 1. Same sign, has to be negative. See, there's a negative, and that determines that. And then all I'm doing is looking for products of C that give me B. Products of 2, here's my negative. The same thing, the same sign. I'm just going to add them up, and they should give me the 3. So the 2 and 1, negative sign because of that negative. What about ax squared plus bx minus c? Now this is a little different. The only way I can get this negative sign is I have opposite signs. So I go ahead and I write, here's my opposite signs, and then I have to figure this out. Now here they're not going to add, they're going to be the difference of two things, not the sum. B is not the sum of these two factors, it's going to be the difference. So let's look at this case. I've got x squared plus, I'm going to put my plus and my minus because of that negative sign, they have to be opposite signs. And now I'm looking at two factors, the difference would be plus 3. So here's 10 and 1, the difference would be 9. 2 and 5, 5 minus 2 gives me the 3. So 5 and 2 is what I'm looking for. The sign of this tells me which one the larger is. So that's x plus 5, x minus 2. And let's do it over. X squared minus 2x plus 5x would give me the plus 3x, and then the plus 5 times the negative 2 would give me the negative 10. So here I've got an ax squared minus bx minus c, alternate signs. Here I need to do the negative, so I'm going to put the negative first, and that's going to be the sign of the larger factor. So here I've got the 10 again, the 5 and the 2, the difference being 3, but now the sign goes with the larger, the negative goes with the sign of the larger, which is the 5. So factoring a quadratic trinomial, here's the solution. We're going to take this. Remember we said see if we can factor out the highest, greatest common factor. That would be x. I need to take out of x, so I take out of x. And the greatest numerical factor would be the 5 in here. So if I took out a 5, I would have a 2x squared. The 5x would be the 2x squared plus 21xy because I've taken out one of the x's, and then the minus 11y squared. And now I'm going to take this and see if I can factor it. So here is my trial and error. When this is not 1, it's more of a trial and error process. But I have some things that I can go by. If I had two factors, this needs to be a y in here. That needs to be an x here, so I do have a y and a y, an x and an x. Needs to be the factors of this, so I would do like a 2x and a 1. That's the only factors of that. And then I look factors of 11. Well, I've only got 11 and 1 here. Okay. And then I'm just going to try trial and error. Basically, that's going to see if I give it to me. So I'm going to do the 2x, 11y, x minus y. So I'm going to do it in this form. That would give me the 2x squared minus 2xy plus 11xy. That gives me the plus 9xy minus 11y squared. That's not what I've started with, so that's incorrect. I'm going to swap these. In this case, I get the 2x squared minus 22, I'm sorry, the minus 22xy plus yx gives me the minus 21xy, and then the minus 11y squared. Notice in each case, this is correct, but this is adding up to be a different one. Now I'm going to change the sign, okay? And I keep my 2's here, but I'm going to change this one. So now I'm going to be a minus 11y, x plus y. 2x squared plus 2xy minus 11xy gives me the negative 9xy, and then the minus 11y squares, these don't add up. And my last possibility is the negative, and change those signs. So here I get the 2x squared plus 22xy minus xy gives me the 21xy, and then the minus 11y squared, and that is correct, so that's the factored form. So what would happen if none of these turned out to be the middle thing when I added them up? Then it just couldn't be factored. We'd have to look at something, some other way to do what we were about to do. Here's a couple of special ones. A factored form of a sum and difference of cubes. The sum and difference of two cubes. So here's the sum of two cubes. It is just a plus b. That sign goes with that. And then I'm going to switch this sign times a squared minus ab plus b squared. Notice that I'm missing that 2 that came with when I was squaring a perfect square binomial. A cubed minus b cubed, same sign. A minus b, this one flips here, the opposite sign. So opposite, same, then opposite. Same, then opposite. A squared plus ab plus b squared. And at times I need to go back and forth. I recognize this. I could just replace this. Here I need to go here. Okay. So let's look here. X cubed plus 125. I say, oh, I got one cube. Do I have another one? I take the cubed root, which is the 5. 5 cubed is 125. And then I can just quickly factor. X plus 5, same sign. Square, x squared. Change the sign. Just multiply the 2 together. 5x. And then square the last one plus 5 squared. That gives me x plus 5, x squared minus 5x plus 25. Same thing here. 2m squared. This is still the same pattern. I'm going to take the cubed root. I get a 2m squared. So that's 2m squared cubed. Cubed root, that's 3n. Cube that, and then I can just go 2m squared minus 3n. 2m squared squared plus multiply the 2 together. This times that gives me the 6m squared n, and then square the last one, the 9n squared from there. And then we simplify. So this is kind of our factoring guidelines. Our first step is try to factor out the greatest common factor. If I've got 4 or more terms, try factoring by grouping. This is kind of our only thing when we've got multiple terms and all these terms are different. If I've got 3 terms, is it possible that they're perfect? A squared plus 2ab plus b squared, then I can just write it as a plus b squared. A squared minus 2ab plus b squared is just the a minus b squared. Okay. I take the square root of the first one, square root of the second one, multiply them together and double and see if that's that middle term. Otherwise, try factoring by the trial and error method. Okay. If I've only got 2 terms, I'm looking and seeing, are they the difference of 2 squares? Then I can write them as a plus b, a minus b, the conjugate pairs. Sum of cubes, if I've got a cubed plus b cubed, then I can use my factoring rule, a plus b, a squared minus ab plus b squared, plus, change the sign for this one, a cubed minus b cubed, same sign negative for the a minus b, and then I change the sign for the plus ab. So a sum of squares, a squared plus b squared, here's they just making a note, cannot be factored over the real numbers. We'll talk about complex numbers later on. So right now we can't factor that. Just got to give up. So let's look at another one. Factor completely. X to the fifth minus 9x cubed plus 8x squared minus 72. Any GCF? No, there's no common x's and there's nothing common factors between these. So I'm going to try to group them together, the highest. I can take out an x cubed x squared minus 9. And then this take out an 8x squared minus 9, because I'm really looking if I can get this to look like that. In this case I can. 8x squared minus the 72. I take out the x squared minus 9. I'm left with the x cubed plus 8. And now look what I got. A difference of two squares, x plus 3x minus 3. The sum of two cubes, x plus 2, x squared minus 2x plus 4. So we kind of continue doing and applying our rules as we can. So this polynomial, they would have factored completely the 25 minus x squared minus 4xy minus 4y squared. So here, it's got four terms. However, the standard grouping method does not work, even if we try rearranging terms. Okay? But I can do this. I can say, look, I've got this little piece here. It looks like that's a perfect square, maybe. So I take out my negative. I want to take out the negative over here. So I got the 25 minus this. Square root of x squared is x. Square root of 4y squared is 2y. X 2y doubled is the 4xy, so that's a perfect square. Collapse down to the x plus 2y, the square root of that. And now I've got the difference of two squares. 5 minus x plus 2y, 5 plus the quantity x plus 2y. And then I can just drop this if I need to, or leave it there just to recognize what we have. Here I've got x squared minus 5 squared plus 2x squared minus 5 minus 24. That looks like, if I looked at this, it looks almost like the very same thing as a quadratic. And this is called a quadratic form. So what I'm going to do is I'm going to do a little change of factors here, a change of variables. So I'm going to say, what if this was a u? Let u is equal to x squared minus 5. There's that one. So this is really u squared plus 2u minus 24. This makes it easier to recognize that I can factor these things. Two factors of 24, the difference, because of that negative giving me 2, that's the 6 and the 4. Gives me the 2. Same sign here with the larger. And then basically I just go back through and put what was u, that was my x squared minus 5. I just replace back again to what I had. It just helps me try to recognize this. But look what's happening here. When I simplify this, I get x squared plus 1, x squared minus 9. This I can't, I've got the sum of two squares. I can't do anything with that, but this one I can. The difference of two squares, x plus 3x minus 3. So some polynomials cannot be factored with the techniques we've learned so far. For example, no combinations of binomial factors with integer coefficients will produce this trinomial. I go through all of the things that I can try, and I just can't get them to add up if I try to do this. Factors of here's only 5 and 1, and the 3x and the 5 is this. And if I try the various versions, I don't get it. Here's my various. This gives me 3x squared plus 8x. If I flip these, I get the 3x squared plus 16x. Neither one of these gives me the 9x. So what I call in this case is that we say that this polynomial is a prime polynomial. Its only factors are 1 in itself, just like a prime number. Okay? So many polynomials cannot be factored. There's lots of prime polynomials. You just have to kind of go through trial and error and then recognize they can't be factored. Here's some more that we can take out a greatest common factor. In this case, the greatest common factor is x to the fourth. There's no factors in common between 2, 5, and sine. They're all relatively prime. I take out the x to the fourth, so what am I left with? 0 here, or just 7. 1 here. I'm taking out the 4 here, so I've got the 2 here. Now I can look and see if I can factor that one. Again, let me try this one. I'm going to take out an x to the negative fourth. So I got an I want to do the x to the negative 6 here. I want to take out the largest with the negative exponents. So if I pull out an x to the negative 6, I get a 2x to the 0. That makes that positive. I'm taking out a negative 6. That gives me a plus 1. Negative 6 gives me the 7x squared. So I've turned a piece with a negative exponent and a piece with all positive exponents. And then I can look at other things. Okay. And equivalently, when I multiply this out, this is 1 over x to the 6. That's 2 over 1. So this is equivalently what that looks like. So that's the end of our lesson on factoring. Please go and work at many problems as you can find. Go to the textbook, look at the odd numbers. We'll be going back and forth. That skill is just highly used, and the more you practice, the better you'll be. So I'll see you next time. Have a good day.